There have always been power disturbances, such as those you saw in the previous segment, associated with the operation of transmission and distribution systems. In the past, these disturbances often went unnoticed because power-consuming equipment, especially electromechanical devices, was not very sensitive to power disturbances. The difference between then and now is that what was considered good power quality then may not be considered good power quality today. That's because some of the equipment used today, especially microprocessor-based devices and electronic equipment, is more affected by power disturbances than equipment used in the past. But just where is this more sensitive equipment? Is its use widespread enough to be concerned about? Well, just about every customer, residential, commercial, or industrial, owns equipment that can be profoundly affected by power disturbances. This is true even if the disturbance is for a very short period of time or of a very small magnitude. Although some power disturbances may seem small and almost insignificant, they can make a big impact on the electronic equipment that's commonly used today. You've probably seen the damage that's left behind after a thunderstorm. Blown lightning arresters, burned out transformers, and switches and other equipment that's flashed over to ground. A lot of the damage is the result of lightning strikes. Lightning strikes can introduce abnormal conditions, such as surges and spikes, into a T&D system. Well, in some respects, a printed circuit board in a computer is just like a transmission or distribution system. Disturbances in power quality are just like thunderstorms. Although the scale is smaller, they result in the same type of devastating effect. Just as utilities use lightning arresters to help protect T&D equipment, customers use power line conditioners to help protect sensitive equipment from the effects of different power quality problems. The term power line conditioner can mean many things to different people, and not all power line conditioners solve the same power quality problems. Three common types of power line conditioners are surge suppressors, motor generator sets, and uninterruptible power supplies. Every type of power line conditioner has its advantages, but it also has shortcomings. Each customer has to decide which type to use based on the type of problem they have. A surge suppressor is a device that diverts a surge to ground. The amount of energy that a surge suppressor can absorb is directly related to its rating. A motor generator, or MG set, consists of a drive motor that is mechanically connected to an AC generator. An MG set generates a new voltage waveform for the load. As a result, it isolates the load from disturbances on the power system. An MG set can also help shield a load from sags, swells, and surges because of the inertia supplied by the motor. An uninterruptible power supply, or UPS, is a common solution for power outages that last more than 1 second. Using battery-powered circuits, a UPS can provide enough power to allow operators to shut down equipment in an orderly fashion. Customers use power line conditioners because of the concerns they have for the proper operation of their electrical equipment and appliances. However, you need to remember that a utility has both residential and commercial customers, and that each type of customer has their own concerns. Let's take a few minutes to see what kinds of concerns each of these two types of customers has about power quality problems. We'll start with residential customers. As technology has advanced, residential customers have acquired devices that are increasingly more sensitive to power problems. As a result, customers are more aware of power quality issues than ever before. For example, electric clocks can stop when a sag or an outage occurs, and then start up when the power returns to normal. Unfortunately, the clock may be off time until someone resets it. Digital clocks sometimes have a memory feature that allows them to retain the correct time if the power disturbance lasts less than a few seconds. Any longer than that, however, and the customer will have a house full of blinking clocks. Microwave ovens and televisions are other high-technology devices that are profoundly affected by power disturbances that commonly occur in residences. Also, more people work out of their home or are electronically connected to their company. For these people, power disturbances can mean a loss of income. In addition, lights in a home are subject to flickering. Flickering lights are an annoyance. They can also cause physical discomfort or even illness. Power disturbances also affect commercial establishments. Flickering lights are as much a problem in a business environment as they are in a residence. These days, just about every business has a computer system. In both commercial and industrial environments, these systems handle a company's records, including payroll, inventory, and operations. Computers are very sensitive to voltage disturbances. A surge or sag can bring a computer down if there are no adequate backup capabilities or power line conditioning. Also, in industrial environments, an extensive amount of electronic equipment is used to control plant operations. These electronic systems are affected by power quality problems in much the same way that computers are. Motors in a plant can also be affected by power quality problems, especially harmonics. And manufacturing plants stand to lose hundreds of thousands, even millions of dollars in lost revenue as a result of downtime and eventual restartup. In addition, power quality problems such as harmonics can severely affect the operation of the equipment in a plant, even if the plant is not shut down completely. This can be extremely frustrating when the problem is present on the system because of a third party. There's nothing to repair at the complaining customer's site, and the utility cannot adjust its own equipment. What the utility must be able to do is alleviate the effects of the problem at the complaining customer's location. That's why it's important for you to be able to recognize quickly what type of problem you're dealing with and then work effectively to eliminate the problem. When we return, we'll look at power quality from the utility's point of view.